All right, let's take a look at the answers for the questions for exercise 2.3 starting on page 52. So I had assigned 3 to 19. So I just alternate the colors here so you can tell the difference. But this is just a walkthrough of each of the answers. I'm going to go kind of quick. You can check the number, like the actual number for the answer in the back of the book. These are just the calculations and approach that you would take. So for number 3, how many ways can a committee of at least one person be formed from 7 club members? Well, if you have at least one person, so you can pick 1, 2, 3, 4, 5, 6, 7, up to 7 spots. So you can either pick a person or not in each case. So times 2. So pick a person or not, 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 so on and so forth. And then we subtract 1. It also works out that that's just 2 to the power of 7. Whenever you just have 2 options, you can do 2 to the power of and subtract. In the next case, Chang arrives at a giant auction sale late in the late afternoon there, and there are only 5 items left. So how many different purchases can he make? So again, same kind of idea as the previous one. You either buy an item or you don't. So you can buy an item or not. There's 5 items there, so 2 to the power of 5 minus 1. Number 5a, how many different ways could a team of 3 students be chosen from Lynn's finite mathematics class of 25 students to compete in the county mathematics contest? Well, there's 25 students. We want to pick 3. So 25, choose 3. In the case where we're including Lynn in part B, well, then it's 24, choose 2. We take Lynn out of the equation. We only have 2 students left to pick and only 24 students to choose from, so 24, choose 2. And then finally, how many cases would Lynn be or not be a team member? So how many cases would Lynn not be a team member? Well, A was our total number of possibilities with as a member, and then B was not a member, so we just subtract those 2. Number 6, 12 dots are on a page of Pierre's dot-to-dot puzzle book. No 3 points are collinear. How many straight lines can he form by joining the dots? So again, this is that idea that there's no 2 dots, or no more than 2 dots are in a straight line. Well, he's got 12 different dots on there. He needs to choose 2 to make any straight line, so 12, choose 2. Moving on to number 7 here. Number 7, how many different sums of money can be made from a $2 bill, a $5 bill, and a $10 bill? Well, this is like the coin problem from the examples before. Choose the bill, choose the $2 bill, choose the $5 bill, choose whether or not you have a $10 bill, and then take away 1 because that'll remove the case where you have picked no bills at all. When you add an extra $10 bill in there, it's just the same. We just bump up the 3 options for the 10, 1, 2, or 0, and then we subtract the 1 still. When you start throwing in $5 bills, because we're asking for sums of money, 2 $5 bills are going to be equal to 1 $10 bill. Thus, it's going to throw in an extra loop because you're going to have to figure out all those cases where there's 2 5s instead, or is there 2 5s or a 10. Number 8, committee of students and teachers being formed for the parking lot issues. So you have 15 staff members, 18 students, and you want to have at least 1 student, 1 teacher. So this is the case where if we take a look at how many ways can we pick no students, how many ways can we pick no teachers, and take those away from the total, the indirect method will be left with our result. So there's 33 in total. So, choose 5 people, subtract the 15, choose 5. Just picking from the teachers only, so there'll be no students. And 18, choose 5, just picking from the students only, subtract those out, and you got yourself your answer. Number 9 here, we are looking at the binary number system, working with only 2 digits. So everything's represented by sequences of 0s and 1s. So 4-digit binary number, how many ways can you, or how many different numbers can you make? Well, you either have a 1 or a 0, 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 or 2 to the power of 4. There is no subtract 1 in this case, simply because it's okay to have 0, 0, 0, 0. It would represent the number 0. If you had 8 spaces, 8 digits to choose from, then you'd have 2 to the power of 8 as your possibilities, or 2 times 2 times 2 times 2, so on up to 8. And then how many do we need to represent our whole alphabet? Well, we have 52 characters in our alphabet when you use the capital and lowercase letters. And so the next closest power of 2 that's greater than that would be 2 to the power of 6. So 6 spaces. Number 10, from a deck of 52 cards, how many different 4-card hands can be dealt with, which include 1 card from each suit? Well, hearts, and I don't know if you can quite see that there. Let me see if I can adjust this a little bit. There we go. So hearts, suit, 13 hearts, choose one of them, 13 spades, 13 diamonds, 13 clubs, choose one in each case, or it could be 3 to the power of 4 as well. And then finally, moving on, make sure okay, it's there. Number 11, and the last set here, and we'll be done. Number 11 says the prime factorization of 12 is 2 times 2 times 3. Remembering that 12, 1, 2, 2, and 3 are the smallest, are the numbers that divide into it. Or sorry, 1, not 12, divide into 12. So 2, 1, 2, 3, and 3, or 2, 2, and 3. I'll get that right. 12 has 1, 2, 2, and 3 that divide into it. So we ignore the 1 because it doesn't make much of a difference in any multiplication. So creating those numbers, that'll work. We could have like 2 times 2, 2 times 3, 3 times 2 times 2, are the options there. So we have choices for 2s. We can use 1, 2, or no 2s. We can use 1, 3, or no 3s, and then take away the case where we use no numbers. Number 12, using that same principle, in this case 540 has 2 times 2 times 3 times 3 times 3 times 5. So you can pick 1, 2, or 0 2s, 1, 2, 3, or 0 3s. Use the 5 or don't use the 5, and then subtract the 1 in the case where you've used them all up, or where you haven't picked any. Number 13, there are 14 teams competing in the Built-in Community Dart League. Teams are selected for the first and second divisions, so we're picking for 2 divisions. We're going to need 7 teams in each division. The first place team from the current first place team is going to be in the second division, and last year's champs are automatically in the first division. So we just completely disregard them. We now have 12 teams to pick from, 6 go in Division 1, 6 go in Division 2. So 12 choose 6 for Division 1, and then the remaining 6 choose 6 for Division 2. Number 14, Marla's picking some marbles out of a bag, and there's 2 red, 3 blue, 5 green marbles. If she reaches in randomly without looking, how many can she pick out? Well, she can either pick 1, 2, or no red marbles, 1, 2, 3, or no blue marbles, and then 1, 2, 3, 4, or 5, or no green marbles. So those are our options. Take away the 1 for the case where she doesn't grab anything out of the bag. Number 15, we have a rail car compartment with 4 seats facing the engine, 4 seats not facing the engine compartment. And so you have 8 passengers, 3 of them want to face away from the engine, 2 want to face the engine. So that leaves 1 seat facing away from the engine, and only 3 people left to fill. So 3 choose 1 to fill that 1 seat, and then there's only 2 seats left for the other, and 2 people left, so 2 choose 2 to get the other side, and we just multiply those out for our total combinations. Number 16, travel agency has a limited number of 6 different free pamphlets about the Beetle Islands. You can take any one that you want, but you can't take more than 2 of any kind. So assuming you take at least 1 pamphlet, how many choices could you make? Well, for that, you could choose 1, 2, or no pamphlets in each case. There's 6 different pamphlets to choose from, so it'd be 3 times 3 times 3 times 3 times 3 times 3. I think that's it. Anyways, it's 3 to the power of 6, and we take away that 1 case where you didn't pick any pamphlets. Number 17, to note here, there's an asterisk beside it because there is a mistake in the back of the book. The answer in the back of the book is incorrect. I don't even know how they got at it, or what numbers worked out to that. But the result here, we got Lisa. She's going to take 9 courses in her first year of college. She has to take at least 2 science classes. So let's take a look at the cases where she doesn't take any science classes and the case where she takes 1 science class. Otherwise, we got to do 5 science classes, 4 science classes, 3 science classes, 2 science classes. So we can either do the direct method and do 4 cases, or indirectly, and just do 2 where she doesn't fulfill the requirement. So, total number of ways of picking courses in general is 17, choose 9. If she picks no science, she's got 12, choose 9 there. 12 courses are remaining that aren't science, pick all 9. And then if she picks only 1 science class, we do 5, choose 1 of those 5 science classes. And then there's 8 courses remaining to fill, so 12, choose 8. We multiply those, and then everything is subtracted there. 17, choose 9, minus 12, choose 9, minus 5, choose 1, times 12, choose 8. Remember, order of operations, this gets calculated first, and the answer should be 21, 16, 15. Or sorry, 21, 6, 15. Last 2 here, number 18, we have the science club members work in pairs in an experiment. If there's 8 members, how many ways can you make pairs? Well, for the first pair, it's 8, choose 2. And then there's only 6 kids remaining, so 6, choose 2, and then 4, choose 2, and then the 2 kids remaining, 2, choose 2. Multiply those out, there's your total combinations. For part B, again, we can take a look at an indirect method here. We want to see how many ways that Lewis and Simone will not work together. So if they're working together, right there, 2, choose 2. We're picking Lewis and Simone to just work together automatically. That makes a 1. And then we have 6 students remaining, so 6, choose 2. 4 students remaining, 4, choose 2, and then 2, choose 2 for those last 2 students. So here's the big part here. We're just picking those remaining students, and we're basically, this is ignoring Lewis and Simone. We subtract that from the total, which we got in A. That'll give us a result. And finally here, for the last one, just make sure that's down so you can see it. If she picks, or she's picking books, Josie's picking either a mystery or a biography off the shelf, and then Juan has to go in there and pick a book, both a mystery and a science novel. So if she picks a mystery novel first, then there's 6 options, choose 1, and 8 options, choose 1. So there's 48 possibilities there. And then if it takes a biography off, then there's still 7 mystery novels and 7 biographies, so choose 1 in each case. You're going to get 49 biographies and only 48 mystery choices, so better off pulling that biography choice off.